Guided exercise number 1 says determine the Riemann sum for f of x equals 1/2 x squared plus x minus 1 on the closed interval -1 to 2 using 6 subintervals of equal width and choosing the evaluation points to be left endpoints. Illustrate the Riemann sum using the graph below. What are we approximating now? So, at least for a little while, let's ignore the graph and let's just go on autopilot and do what we're used to doing. So we'll do delta x is going to be 2 minus -1 all over 6. So that's a half. Write down our subintervals. So our subintervals are -1 to -1/2, -1/2 to 0, 0 to 1/2, 1/2 to 1, 1 to 1.5, and then 1.5 to 2. Double check that we have 6 subintervals, but we do. We have the right number, and we have the right ones. And we're supposed to use left endpoints. So let's just go ahead and mark those. So the Riemann sum formula is exactly the same formula that we were using in the previous 2 sections. And so to do the Riemann sum with 6 subintervals, we'll do f of -1 times 1/2 plus f of -1/2 times 1/2 plus f of 0 times 1/2 plus f of 1/2 times 1/2 plus f of 1 times 1/2 plus f of 1.5 or 3/2 times 1/2. And this is not a super great function to be working with. What I'm going to do is I'm going to write down the function values that I worked out, and then you can double check me on that if you'd like. So I'm going to make a t-chart. -1, -1/2, 0, 1/2, 1, and 3/2. Okay. So again, we're gonna go back to the graph. I haven't forgotten. So I get -3/2. I get -11/8. I get -1. I get -3/8. I get 1/2, and I get 13/8. And so these are the things that go into the sum. I'm going to go ahead and take that 1/2 and pull it out of everything, and then add f of -1, f of -1/2, and so on. So let's see, -3/2 plus -11/8 plus -1 plus -3/8 plus 1/2 plus 13/8 is what this works out to be. Okay. And for purposes of making an illustration, I'm going to write this in kind of a silly way. This is -3/2 times 1/2 plus, so this is the, what are we approximating now? This will help us see, -11/8. And actually, I'm going to take it back. I'm going to factor that negative all the way out. Negative. So 3/2 times 1/2 plus 11/8 times 1/2 plus 1 times 1/2 plus 3/8 times 1/2, and then plus 1/2 plus 13/8. So do you believe me that this is really the same thing as what we had before? For purposes of calculating the Riemann sum, I would absolutely stop here. But the reason that I kept going is to write this in a particular way so that we can compare with the picture. So let's go up to the picture. So let's mark our subintervals. Okay, and then we're supposed to be using left endpoints. So if you mark f of -1 on your graph, you're down here. Well, let's go ahead and use that height to draw our rectangle. So this rectangle's area is 3/2 times 1/2. You see that in the Riemann sum, it's there. And then the next rectangle, let's just keep blue. We use the left endpoint and go till we hit the graph, and then draw across to make our second rectangle. Its area is 11/8 times 1/2. The next one, its area is 1 times 1/2. And all of those things show up in our Riemann sum, but they show up with a minus in front of them. The next one, I believe that was a 3/8. Yes. The area of this rectangle is 3/8 times 1/2. And then those last two, let's make them brown. Left endpoint, go across, make your rectangle. Left endpoint, go across, make your rectangle. Those areas are 1/2 times 1/2, and then 13/8 times 1/2. So compare the numbers that we got here with that kind of silly way that we wrote down the Riemann sum, and you can see what's happening in our Riemann sum is we're doing brown areas minus blue areas. So what this looks like is brown, or total brown area, more precisely. Total brown area minus blue area. And what that's approximating isn't just the plain old area anymore. What we're approximating is the areas above -1, 2 minus areas below -1, 2. So that's what our Riemann sums do in a more general sense. They approximate areas above minus areas below.